wouldn't have anything about this. This is just an idea for the next lesson, which will be for the exam.
Or maybe they'd ask you the definition of conservation of energy.
That would be, the definition would be the only thing they could ask, but as we see, a lot of people already knew this one. Okay, let me just alright. Okay, next. So we'll just do a little bit of this. What day is the exam next week? Tuesday.
Yep.
The first physics class of the week. Do we have physics yesterday? No. Okay. This time next week. Okay.
Will we have it here?
It's in class as normal. Yeah, so it'll be in here. Yeah.
Will it be
1 hour
like
laptops?
Yes.
2 hours?
No, 1 hour.
Even physics is only that.
Yeah. Yeah. Okay, can you write this down? Kinetic and potential energy.
Half mv squared.
Prove it. Have you seen the proof of the formula?
I remember that it's really long.
Not really long.
Yeah.
Okay, you got
Does
this?
this have to do with the triangle?
Triangle. What triangle?
Half base, half and
Not yet, not yet.
No, that's what I heard square.
I don't know what you're talking about. We'll see. If an object, hey. If an object is moving, then it has kinetic energy. Where did it get this energy? Well, somebody must have pushed it. Applied a force. This energy is from some work being done. That is, kinetic energy equals work done to give it that energy. If a mass m is moving with speed v, then how much kinetic energy does it have? Let us see. So, this here is moving with a velocity v. So it has kinetic energy. Where did it get this energy from?
Force.
From a work done by a force, somebody was pushing it. So at the very beginning, what was its speed? 0. Somebody pushed it and made it move. Now it has energy. It got this energy from the work being done. Let's work out what that is. What is the work done? Let me just be more clear here. The kinetic energy, Ke, is the work done. What's the formula for work? Force times distance, which is F, which is F times S, which is ma times S, which is m, and then we need to work out what the a is. So, we have U is 0, V is V, A is A, T is T, and S is S. The only thing we know is the U. I'm going to use a formula to get the A. I'm going to use V squared equals U squared, but what's U squared? 0. So V squared equals 2AS. So what does A equal? It will be V squared over 2S. So this A is V squared over 2S times S. What happens here? Cancel. So you're left with a half V squared. And you're thinking, hey, I know this formula. I remember my physics teacher showing me this. I just pulled that 2 out into the front, yeah. So we have our first formula for this lesson. Kinetic energy, the energy something has because it's moving, is equal to half its mass times its speed squared. First formula for today.
You need to know how to...
No, you don't need to. Okay, you got that formula? The proof you don't need for the exam, but it's very, very good to understand it and to see it. And I would still like you to write it down. Okay?
What about the E?
Yeah.
Continue now?
One.
Okay, yeah, go ahead. Continue, not sure. Yeah. Okay, so the next one is if an object is at a height h above the ground, then it will have potential energy. It got this energy because someone did work on it. That is, a force brought it up to this height. So, potential energy is the work done to give it that energy. If it's mass m and height h, then how much potential energy does it have? Let us see.
So the K equal PE.
For this one it will be, yeah, but maybe we could do it a different way here. Think about it like this. There's two proofs for this. You've seen one proof. I'm going to do a different proof for you. So here is a box here of mass m. When it's up here, it has potential energy because it could do some work. If you let go and drop it on someone's head, you have done the work of killing them. Congratulations. Assassin's Creed Physics Edition. Now, the potential energy it has is equal to the work done to give it that energy. And how did it get up here in the first place? Somebody applied a force to move it up here. So it got this energy from this force. This has a weight of mg. So what is the force required to move this steadily up? mg, at least mg. So if you want to move this up, how much force do you need?
Bit more than
Yeah, but we'll just say mg. What is the force? mg. And if you moved it up, the distance is h. So potential energy is mgh.
Yeah, what about the people who doesn't have a magic, or they like take a box of
Start again? Yeah.
there are some people they move the box or anything
Yeah.
without anyone.
No, that's not possible.
Magical energy.
No, really, like I see it before, and the most of the people see it like there
No,
are
no.
people
Magician.
No, it's a trick. It's just a trick, I promise you. We do not have magical energy.
But you do see it before?
I know what you're talking about, but it's a trick. It's not real.
Believe in magic. He feels physics.
No, yeah. Okay. Continuing. Right. You have potential energy. Yeah. Can I go back to the slides? Right. So, I think we'll just finish on this one. Potential energy is positive, then we say the object has potential energy. If it's zero, then we say it's free, and if it's negative, then we say it's trapped. Now, you will forget this from semester 2, so please do not forget it. I'll draw a picture to help explain what I mean here. If the potential energy is positive, then it has energy and it can do work. In this case, you could again do the work of, yeah.
If you fall, you're dead. You
Well,
don't
we'll-
have energy and you're zero.
We'll say the work is killing someone, perhaps by landing on them. I don't know. So if the potential energy is positive, then it has potential energy, of course. If the potential energy is zero, then we say it's free. it can just, it's free. It doesn't have energy, or it can't do work. It just is free. But more interestingly, if the potential energy is negative, because the height is negative, for example, then we say it's trapped. So I'll give you a good example. When you have your electron in an orbit around a proton, you must give it energy to be free. What do you call this in chemistry? Ionization. Yes, you've done this with your chemistry teacher? Ionization. So right now, when the electron is trapped, you are able to say its potential energy is negative. It means that you must give it energy to be free. And when it's free, its potential energy is 0. Okay, so there's a little bit of vocabulary here I want you to note. Positive has 0, free, negative, trapped. I've already... Okay, we'll finish it there. So, positive has 0, free, negative, trapped. Okay. You'll need to stop it there. Don't worry, I'm going to continue from this slide in the next class anyway. Right, those two people, just put it there on the table so I can take